Assalamualaikum. Today I want to discuss on commonly used thermionic emitters. The high temperatures needed for satisfactory thermionic emission in vacuum tubes limit the number of suitable emitters to such substances as tungsten, thoriated tungsten, and certain oxide-coated metals. Now, firstly, we will discuss on the tungsten. It was the earliest material used as a cathode and has a slightly higher work function, such as 4.52 electron volt. The important factors in its favor are high melting point, 3650 Kelvin, greater mechanical strength, and longer life. The disadvantages are high operating temperature, 2500 Kelvin, high work function, and low emission efficiency. Therefore, it is used in applications involving voltages exceeding 5 kV, such as in X-ray tubes. Now we will discuss on thoriated tungsten. A mixture of two metals may have a lower work function than either of the pure metals alone. Thus, a tungsten emitter with a small quantity of thorium has a work function of 2.63 electron volt compared with 3.4 electron volt for thorium and 4.52 electron volt for tungsten. At the same time, thoriated tungsten provides thermionic emission at lower temperature, such as 1700 degrees Celsius, with consequent reduction in the heating power required. In the manufacture of this type of cathode, tungsten filament is impregnated with thorium oxide and heated to a very high temperature, 1850 degrees Celsius to 2500 degrees Celsius. The thorium oxide is reduced to metallic thorium and coats the filament surface with a thin layer of thorium. Thoriated tungsten cathodes are used for intermediate power tubes as voltage between 500 to 5000 volts. Here we can see a picture of thoriated tungsten. Now we will discuss on oxide coated cathode. This cathode type consists of a nickel ribbon coated with barium and strontium oxide. Oxides of any alkaline earth metal such as calcium, strontium, barium, etc. have very good emission characteristics. In the manufacture of this type of emitter, base metal like nickel is first coated with a mixture of strontium and barium carbonates. It is then heated to a high temperature in vacuum glass tube until the carbonates decompose into oxides. By proper heating, a layer of oxides of barium and strontium is coated over the cathode surface to give oxide-coated emitter. The oxide-coated cathode has low work function, 1.1 electron volt, operates at comparatively low temperature 750 degrees Celsius and has high emission efficiency. However, the principal limitation of oxide-coated cathode is that it cannot withstand high voltages. Therefore, it is mostly used in receiving tubes or where some voltage is involved do not exceed 1000 volts. Now we will compare these three types of emitter. Number one, for tungsten emitter, work function 4.52 electron volt, operating temperature 2327 degrees Celsius and emission efficiency 4 milliampere per watt. And second emitter types is thoriated tungsten and has work function 2.63 electron volt and operating temperature is 1700 degrees Celsius and emission efficiency is 60 milliampere per watt. And third is oxide coated emitter and work function is 1.1 electron volt, operating temperature is 750 degrees Celsius and emission efficiency is 20 milliampere per watt.